I do want to begin by thanking Merle for the invitation to gather and discuss my work with you. But before I get started, my student Alexander Lutzovich, who presumably is watching now, tells me that Professor Dietrich Dorner of Bamberg is joining us today. I've not seen Professor Dorner for years, maybe decades. And of course, I've still not seen him, but I do want to give him my heartfelt thanks and thank him for tuning in. So I'm going to be talking about the expertise approach to joint action and have some points in commonality with some of the other speakers, but more a slightly different take on joint action and maybe a higher level talk than our previous two speakers. Our challenge here, as I see it, is to go beyond the 1 hour study of joint action. There's so many papers that are less than an hour long that take place in the laboratory. I've sort of been fighting this trend for the last 5 years in my own work on individual expertise, trying to look at changes over time, both in the lab and in the real world. I want to say, my firm belief is you don't get a whole lot out of a 1 hour laboratory study with freshmen. We really need to be studying people for much longer periods of time. And that's the bottom line. I'm trying to apply that to joint action as well. So let me see. Let me get started.
Let me see if you can share your slides with us.
Oh, you're not seeing my slides?
Not yet.
Oh, shoot. I am sorry.
No worries. It's nice to see you. Normally people jump straight into the slides and you can only just see a little thumbnail of the person. So that's a nice way to get to know you a little bit better.
My slides are on the screen, actually. And
so just press share screen again, or Alt S, I think. If you press share screen again.
Okay. Well, I'm on a Macintosh, so...
If you go to the bottom of the screen, of your Zoom screen, you should see a big green button that says share.
Okay. Zoom screen. I see a big picture of myself on the Zoom
And then just
screen.
below that, if you hover the mouse to the bottom of that window, you'll see share screen.
I don't see anything at the bottom of the Zoom window. Is there another Zoom window that I should be seeing? Oh, okay. I see you now. Share screen. Okay.
And then you should be able to choose your
My
presentation.
PowerPoint. Oh boy. Okay.
There we go.
Okay. Okay. Thank you, everybody. My apologies. Let me see. So I've been showing you the screen. I think I've been thanking Merle, and I think I also welcome Professor Dietrich Dorner. But I want to get beyond that and get to the talk itself and beyond the technology as well. I'll blame it on negative transfer from WebEx, which is very popular in my university, for better or worse. Let's see. So as I was saying, trying to present what we consider the expertise approach to joint action. In my lab, I've gotten tired of doing these 1 hour studies with undergraduates because I feel you don't really get at real expertise in these sorts of studies, nor perhaps do you uncover the really interesting phases of the phenomena. And it is interesting because thinking about expertise in joint action, I wondered if anybody else had talked about it. I mean, surely they must. I'm not quite sure how to know this for sure. So I did reread recently the wonderful 40-page integrated review by Knobish, Butterfield, and Savants. And I looked for how many times the word expert and expertise occurred. And it turns out in that whole 40 pages, it occurred once in the text and once in the title of one of the 170 papers they cited in that paper. So I guess expertise in joint action is not yet a thing, but I believe it should be. Joint action, first of all, if you're not all that familiar with joint action, let me just say that it neatly divides itself into emergent versus planned coordinations. And emergent coordination entails multiple individuals acting in similar ways thanks to common perceptual motor, perception action coupling. So the classic example would be two people sitting in a chair near each other, rocking and rocking chairs, and beginning to rock at the same pace, not aware they're actually doing this and it's not a deliberate action. I'm not interested in those, at least not for today. My focus is on plan coordination, which is supported by shared task representations and joint perceptions. And a great example of that would be two people making a bed, learning to coordinate their actions and shaking out and tucking in sheets. This is an interesting example because it's also relevant to robotics. Robots have terrible problems dealing with flexible material. People do, but we adapt pretty fast. Okay, and when I talk about expertise, I tend to talk about the task being done, the tools used to perform the task, and the techniques developed to use the tools. Now, experts are not better than novices simply because they have better tools. Rather, they're better because they have mastered the techniques of tool use, which are beyond the techniques mastered by novices. So, novice with the same tools as an expert is still a novice. The expertise approach to joint action requires expertise in the knowledge of the tasks, tools, and techniques you need to do your work, knowledge of your partner's skills, and expectations for how you and your partner will coordinate your separate and your common activities. So there's a lot going on here, right? A lot more than just sitting in a room playing Tetris by yourself or something of that sort. So in the rest of the talk, background section, I'll define some of the terms I've been using and provide brief overviews for some of the ideas that inform our approach. These a lot will be taken from individual cognition studies. Plan coordination, I'll present a very short discussion of research on the joint action of plan coordination. And then I'll talk about the paradigm we're building for ourselves, in which we can study the expertise approach to joint action. It's basically building our own video game, which we hope will be enticing enough that we'll be able to get pairs of people to play for about 15 one-hour sessions, no more than one session per day. So my background, I often like to talk about timescales of human action. This is borrowed this from Alan Newell. And because a lot of the audiences I talk with, they're not just people doing experimental psychology, not just people doing problem solving. They're all over this spectrum. And Newell came up with this time scale basically to be able to talk to people better and say, yes, I understand your work is very important, but it's at this scale and I'm at this scale. That's why I'm doing what I'm doing. Well, my work is sort of at the cognitive band, phenomena which take maybe 1/3 to 30 seconds to show themselves. There's a lot of good stuff my colleagues do in cognitive science, which are at the bounded rationality band, and a lot of good stuff that other disciplines are doing at the social organizational band, and of course the biological band. A lot of great stuff nowadays down there. But you can't study everything. So our focus has been at the cognitive band. You also, as I mentioned in my preamble, can't develop expertise on a task in a 1-hour psychology study. Repeated sampling the same people and/or cross-sectional studies, that is expertise sampling, are required. In one example of a longitudinal study, we had 9 people in our lab for 31-hour-long sessions playing the game Space Fortress. Video games work really well with undergraduates. I can't think of anything else we could have them do for 31 hours that they would actually do. We sample expertise. That's another approach. We realized that Tetris was the most widely played game in the world, and all of our Rensselaer undergraduates played Tetris at one point in their lives. So we now have an hour's worth of play data from each of 400 Rensselaer students. The good news is we have that data. The bad news is that as a group, they're not all that good at playing Tetris. We started going to the Classic Tetris World Championships a few years ago. In fact, that may be going on right now. So don't turn on this Twitch screen until I get off at least, or until this whole workshop is done. But what people do with the same task and tools, but different techniques is truly amazing. It's just not Twitch training that makes a good Tetris player. It's the technique. But in the Space Fortress game, where we collected these 9 hours, 9 subjects, 31 hours data from each of them. If we plot the average of all 9 on their total scores in this game on a typical scale, you see it resembles a typical power function of learning. The interesting problem with this, and one of our big complaints about studying groups, is that we don't have any players who do that. That's the averaged player. But the stuff on the right are the true players, the individual players. There's no average player in there. You don't see any one of those jaggy lines which matches that average player. So whatever the individuals are doing to cause us to have that group average, it's not representative of any one individual. And that's something which the field of cognitive science, cognitive psychology still seems to be very slow to realize. Let me show you some of the changes in play across 248 games. And I'll talk as this speeds up and explain what you're seeing here. The one on the left is one of our subjects during his first hour of play, hour 1, game 1. The red cross which shows up is the point of gaze from the eye tracker. And the gray buttons which pop up and down is an overlay of the keyboard that he was using to guide the piece around and around. But everything else is part of the game proper. On the right side, you see the same player after spending 31 hours on the game. And I think you can be struck by, even if you don't know much about the game, how different the players are. The right way to do this is the way the guy at 31 hours is doing it. Flying very, very slow, very, very close in, destroying those bluish diamonds, which are the mines as they appear, but staying just enough ahead of the space fortress so it can't really get a bead on you. The one on the left is just, completely hopeless, sort of wandering around, not really able to control his own ship, let alone kill mines or worry about killing his fortress too much. So let me stop this. Okay, maybe, yes. So Tetris, anyone? In terms of sampling expertise, we haven't given up on our 500 Rensselaer undergraduates, but we have started going to the Classic Tetris World Championship. And this is the people you see in red t-shirts are me and 2 members of my lab. Ropadinga and Alexander Lutzowicz. And the guy you see on the left there in the blue bandana, he's the Japanese Tetris champion and came in, did very well in the tournament. And you see our banner around there. That's our workstation where we bring people in and try to get the players the day before the classic event itself to play our games of Tetris, where we record all the keystrokes and can examine them in some details. It's truly amazing what these people can do. In terms of Tetris, as I mentioned, we have about 500 hours, 1 hour from each of 500 Rensselaer students, and about 75 hours now sampled from the Classic Tetris World Championship people. We're also doing other things, like we can parse the videos of championship play from 4 or 5 years ago now and get almost the same data we get out of collecting data in real time. The false assertion here is that Tetris is a twitch game, that strong players do the same as weak players, but faster. The true assertion, however, is that the task of Tetris and tools used by players are the same. However, it's the techniques for using these tools that distinguishes the CTWC experts from each other, as well as from the Rensselaer players we get. So, somebody said, why, Wayne, why do you study games? Well, it's sort of like the answer Willie Horton gave, the famous Depression-era bank robber, at least in the US. He was asked why he robs banks, and he shrugged and said, well, that's where the money is. Well, likewise, when people ask us why we use Tetris, our answer is, that's where the data is. Okay. Let me see. Okay, so it's not simple. I mean, the most important part to draw from this section is that acquiring expertise is not simply practicing the same set of techniques or methods until you get good at them. Rather, the plateaus, dips, and leaps approach suggests that most important aspects is the search for exploring the space of techniques. And this is the approach we plan to apply to study skeletal constitution joint action. I see my dogs are awake now. Sorry, I hope you're not hearing that in the microphone the way I am. Okay. So that brings me to joint action per se, because it's a lot of really neat papers in joint action. And I want to talk about a few of them which are quite interesting and intriguing and maybe would benefit from the expertise approach. The big question for my lab is whether we can find a joint action task that will allow us to do the level of detail analysis we've done with Space Fortress, Tetris, and the other game paradigms that we've used. Clearly, there are many good studies out there which use plan coordination, but many of those, at least for joint action, are single session studies. So that tells you a lot, but doesn't quite tell you as much as you want. However, one of the most insightful studies I've seen is the Brenner's Classic 2008 paper. This is a beautiful paper. They had people sitting back where they couldn't see each other directly, but with eye trackers on their heads and looking at things on the screen. Oops, let's see. And they wanted to compare pairs of people searching for O's in a field of Q's across 5 conditions. I'm not going to tell you all 5 conditions, but the best condition was to share a gaze in which both partners of the pair could see what the other was looking, but they couldn't talk to each other. So they could see each other, that they could see their point of gaze, but not otherwise communicate. This beat out the shared voice condition where they could talk to each other, and they had the identical screens, mind you, they had exactly the same screens. But in the shared voice, they could only talk to each other. They couldn't point. They couldn't use their eyes to point. In a shared gaze condition, they couldn't talk to each other, but they did know where the other person was looking. And it turns out that using the shared gaze only, people were significantly faster finding the target than the voice condition, or in the condition where they had a shared gaze, plus they were allowed to talk to each other. Now, this is interesting. People using the shared gaze only were, almost a full second, 767 milliseconds faster finding the targets than those using the shared gaze plus talking plus verbal. Okay, and that's a significant difference. So a priori, I think I would have thought that the 2-person shared gaze search would be much more difficult than a shared voice search, as we might have expected each player's saccades to disrupt the other player's visual search and vice versa. But our friend Brennan and his colleague concluded that searchers appeared able to covertly attend to a partner's gaze cursor in the visual periphery when they desired this information, then to quickly tune out the cursor while refocusing on the search task. This suggests an ability to dynamically adjust attentional control on a moment-by-moment basis. So there's a couple ways of syncing with a partner, changing the topic, moving a little bit from Brennan now. And one is to synchronize the duration of the movement so that your move and your partner's move begin and end at the same time. Okay, that sounds like the definition of syncing. But there's another more powerful or perhaps more complex way of syncing, and that's matching the velocity of your partner's profile so that you and your partner not only begin and end moving at the same time, but you also accelerate and decelerate at the same rate. Such movements can be planned and rehearsed, for example, by synchronous swimmers, dance partners. It's very common. People do this. How do they do it? I don't know. But they can also be considered joint improvisation, for which the mirror game is a really interesting example. If you've not seen the mirror game, I'm going to show you 15 seconds of it right now. Okay, let me stop them right there. I find that amazing. I've watched this, I don't know how many dozen times now, and I still can't figure out who A is and who B is in these pairs. I am sure the players know, and probably our moderator, he must know, but I sure don't. However, it's definitely not a case of emergent coordination. This is definitely plan coordination. It may be an edge case of plan coordination that is right, maybe at the edge of emergent and plan. I'm not quite sure where I would classify it. But what they're doing is pretty interesting case of, yeah, there you go. Have to get the video out. Anyway, and this brings us to another paper I read and liked, one by our organizer and hostess, Merle Fairhurst. And she argues for the study of sensory motor synchronization tasks. And I love this quote from her. In studying human dyads, there is a tension between the need for both interactive online adaptation, are you slowing down, and feed-forward predictive mechanisms, will you go first, for interacting individuals to coordinate successfully. And this is one of the few acknowledgments in the joint action literature that these things are sort of both going on at the same time, and phrasing this way, I think gives a very interesting, slightly different perspective on it. Remember, plan coordination is supported by shared task representations and joint perceptions. Okay. Now, in terms of expertise in joint action, how does cooperative interaction change with long-term practice? That's really the question I'm interested in researching. And that's why I showed you all the slides so far. A 1-hour study is not long enough to explore the full potential of joint action in stable pairs of performers. I'm pretty sure those people in the mirror game we just saw, they're all actors and they've been trained in these techniques a long time. That was not the first time they did these. In common with studies of individual expertise, believe studies of expertise in joint action also require repeated sampling from the same duos. That is, the same people working with each other again and again. We're solving this since I guess we're familiar with games and we've been adapting games, other people's games, so we can collect data from them for the last 5 or 6 years. We decided to see if we could build our own game. A first attempt to build a joint action game to study longitudinal changes in interactive behavior, that is, changes in expertise in joint action. We've learned something, and the first lesson we learned is game building is a lot of work. Fortunately, we had a lot of help. One of my colleagues, Dr. Mike Lynch, is a faculty in Rensselaer's Game Studies program, as well as a member of the Cognitive Science Department. And he and several of the best undergraduate majors from that program helped us get started building our joint action game. Now, lesson 2 is that even with all that help, game building is still a lot of work. And lesson 3 is, iterate on lesson 1. It's a lot of work. We're still not done. But one thing we have done lately is we have a working prototype. And that big red square which comes up is one of the 2 players' point of gaze. In the final game, we're going to have 2 of our acoustic pods wired up to each other, and an eye tracker in each acoustic pod. We're collecting and showing eye data from both these things on the one computer screen. So there'd be only one computer that both players are interacting with to play the game. But we need 2 computers for the eye trackers. And what you see now is, apparently, I didn't realize this until a few days ago, is my student Sasha and his wife demonstrating the prototype of our joint action game. Joint action game 1, we call it. And that's pretty much all we have. We're busily building levels right now. Yeah, let's see. There we go. Go away. Go away. Go away, movie. Okay. They don't like to go. Okay. So our goal for the joint action game, obviously, we're trying to explore similarities and differences between human teams and in a game like this, it'd be really easy to have a human robot team. It could be a real human robot team. It could be two humans with one pretending to be a robot. It could be anything in between. But really the key here is to get started. And our goal is, as I said, and as I show on this slide, is to have 15 to 20 hours from each dyad and to run maybe about 15 different dyads through this 15-hour regimen of 1 hour games. So that means we need a lot of levels. We need to keep them entertained. Each team member would be in a separate acoustic pod. And of course, when you're in a separate pod, how would you know whether your partner is a human or a robot? You see who goes into the other pod perhaps, but you don't know that that guy's just sitting there reading comic books while the robot's doing all the work. Research questions. Well, what shortcuts emerge over time? Something like this. What does each team member learn about the other team member? Can we separate factors due to familiarity with the game from those due to familiarity with my partner? I think these research questions give you an indication of why I responded so strongly when I read Merle's paper. Seem to be on the same wavelength, actually. So the future of our JAG 1, just another game 1, or joint action game number 1. We have been building these different kitchens and different tasks, you know, trying to keep it entertaining, something that our undergraduates or anybody else would not get bored with after 2 hours, something that will keep them coming back. We don't want them leaving. The reason we have 9 out of, for that study with the Space Fortress game, the reason we only have 9 subjects for 31 hours is we started with 15 and 6 dropped out someplace along the way. And it really hurts if somebody drops out after the 10th hour of a 30-hour study. It hurts even more when they drop out the 29th hour of a 31-hour study. But whatever. Anyway, we're ready for beta testing for the human-human teams around the end of this semester. And the idea of human robotic teams will be featured on our grant proposal that we're currently preparing. That we need more resources for. So the future of JAG, the research questions are the same for both human-human and human-robot teams. Basically, with experience in the game and with experience with your partner, what shortcuts emerge? Can we separate familiarity with the game from familiarity with my partner? We're trying to extend studies of joint action to determine changes in interactive behavior which emerge as individuals acquire skill in the task and in interacting with their task partner. And as I said, in the real world, these changes seem to take hours, days, weeks, maybe years of joint action. Can we bring at least some of these phenomena into the lab and study it there? Okay, here's a great case of joint action. Rensselaer volleyball. That's my slide. Thank you.
Well, thank you, Wayne. And yeah, I have so much to say. And first of all, thank you very much for quoting that little sentence of mine. I didn't think it was that good at the time, but thank you all the same. I'd like to pick up on one point, which I think is sort of a really wonderful way of summing up why I did this conference, which was, as I mentioned in Thomas's talk earlier, is why do we do these things? Why do we do things in groups? Whether it's cooking in a kitchen or playing volleyball, because it's hard, right? So why do you do it? And my intuition is that it's fun, but it's fun to learn. But maybe that's just because I'm a geek and that's what I think about learning. But I do think that it's fun to learn, and it's fun to think that you decided to use a game environment, because one always thinks about group interactions, and the word that often comes up is the word play. We play music, we play sports, because when we do things together, often it's in the form of play. So I really think that there's something very nice about you deciding to go the game route instead of the things that I typically do, which is finger tapping or walking. So I really like that. And obviously in the world of COVID, if there's ways to do this online, that's even better. So we can maybe have a think about that, because that's something that's going around in my head at the moment. How can we collect data when we can't get people into the lab? And one thought I've had is that you have these incredible opportunities for exploring expertise over multiplayer game consoles. So you have people who join these squadrons or groups as you know, anonymously at first, or people they don't know, and then over time they rejoin those squadrons, they become friends, and you can then really start to look at some real world ecological data. But in the meantime, your game seems really great. I suppose one of my questions I have for you is one of your questions was, how do you distinguish between familiarity with the tool and familiarity with the partner, which I think is really nice, because we've talked about expertise a little bit as we've run up to your talk today. But I think there's something really nice about that distinction that you made. So maybe you wanted to talk a little bit more about that.
That's a good question, and quite frankly, we're hoping we get some data on things like that, and perhaps we can tease those two apart. I mean, you certainly can think of in our paradigm, after people say played together for 10 hours, well, we're going to have more than one pair do this at a time, right? This is the goal, so we can switch partners on them.
Nice. So we have some questions coming up, which I'm going to switch to quickly because their questions are more important than mine. I have some. There's some comments that there's a really good game called Overcooked.
We've heard of Overcooked.
Yeah.
And you know, we actually contacted those people, and it turns out small game developers are great people. I actually have two small game developers in my family, which is whether I was influenced by my children or they were influenced by me, I don't know. But they're both successful developing in commercial games. They tell me they won't touch this project because it involves doing things that they don't consider games, and it's taken away from their revenue stream and stuff like that. So they're actually not letting me collect the data I need to collect from their games.
Yeah, so that was sort of the question that both Liam and Travis, two people who are part of our program. Obviously, we've just heard from Travis, and we'll hear from Liam tomorrow. And yes, unfortunately, the answer to their question, which is why don't you use the games that are out there, is that unfortunately it's very hard to get access to it and to use that data, which is the issue I'm having. I'd love to be able to get hold of some of these multiplayer console game data.
For the Tetris game, we wrote that ourselves, and we thought we knew what we were doing, and we got it right. But we rewrote Tetris based on specs, and years later, in fact, a month ago, one of the Tetris champions said, you know, your game doesn't quite work like our game, and told us this really, really picky detail, which we had forgotten or not known, and we actually pulled the game off for a week, and because the Classic Tetris World Championships are going on right now. Log into Twitch if you want to see some truly amazing people do things at a third of a second. I mean, you know, it's just crazy.
I was a Tetris geek at one point, so I may just go and do that. But unfortunately, on that note, I'm going to have to switch to our next speaker, Stephen Brown, who's waiting in the wings. But that leaves me just to say thank you once again, Wayne, for your time and for your talk, which got us all thinking a little bit more about expertise and what exactly that means. And we'll hopefully have more from you over the next few days if you're able to join us, and particularly for our workshop tomorrow if you have time. Yeah, without further ado, I'm going to turn to Steve now.
It's the 6 hours time difference, which is the killer. But
I know, I'm sorry. I am all powerful, but that is something beyond my abilities.